So good morning dear students. In today's video lecture, so you're going to start with the actual syllabus. So that is module 1. That is in the module 1, so you people can able to deal with the air standard cycles and the IC engine. So you people can going to get one questions on air standard cycles, because in that air standard cycles you people can going to study with the different cycles, Otto cycle, Carnot cycle, diesel cycle, like that. So that from that you'll get one question, and second half in the first module is the IC engine. So in this video lecture, so I am going to start with the IC engine first. So because in the first half that is about the derivations are there, so that lengthy derivations, so that you can cover it at the end. Okay, so in this video lectures I am going to start with the first module. So in the first module, second part of the content is about IC engine. So that I'll going to start in today's video lecture. So I think all of you aware about the IC engine. So before start with the actual this syllabus, so already you know that what is the engine basically. Being an mechanical students, so you people can know the some basic terminology like what is the engine, motor, pump, like that. So definitions, basically if the word or the term engine will come in mind, so engine means what? That is a device which converts one form of energy into the other form of energy. So that is the engine. So in particular to engine, so if you come with the heat engine, okay, basically in the thermodynamics means you people can deal with about only heat. Okay, so heat engine means what? Basically how you people can define the term or that word heat engine. Heat engine is a device which converts the heat energy released by the combustion of fuel in the engine cylinder into a mechanical work. So that is very important here. So because in the nature we have the different form of energy, so for our utilization purpose you people can going to convert that one form of energy into the other form of energy in the different. Because if you come with the solar energy, again that solar energy is converted into electrical energy with the help of photovoltaic panels. Okay, so in similar way, so because we have the heat energy, because how you make use of that heat energy for some useful work, so you can convert that heat energy into the other form of work, yes or no? So that purpose, if in order to convert that heat energy which is available, so that into a mechanical work with the help of heat engine. Because again how you going to generate that heat, that is very important. Because IC engine means is only deal about it is a combustion of fuel, because we have the different types of fuels in the nature. Either basically you know that about the petrol, diesel, kerosene, coal. Okay, so many fuels are available. So in the heat engines you people can going to use the liquid fuels, so that due to combustion of that fuel, that huge amount or the huge quantity of heat will get generated. So that heat energy you people can convert that into a mechanical work with the help of engine. So that kind of engines you can particularly call it as a heat engine. Okay, so I think you can understand about the term heat engine. Heat engine is, in simple words, heat engine is a device which converts the heat energy released by the combustion of fuel in the engine cylinder into a mechanical work. It's a simple definition of the heat engine. Okay, so next further if you go, so basically this heat engine you can divide into, you are classified into basically two types. One is the external combustion engines and the IC engines. Okay, external combustion engines means what? So the name itself is indicating external. External means what? Whatever the fuel you people are going to use to generate the heat, so that fuel you going to burn it outside the engine cylinder. Okay, so that kind of engines you can call as an external combustion engines. Okay, in a steam engine the combustion of fuel takes place outside the engine, and the steam thus formed is used to run the engine. Okay, basically you can take an example of boiler. Okay, in the boiler you are supplying the water, and in order to convert that water into a steam you can supply the heat energy. Where you going to produce that heat energy? By burning of coal at the other in the oven. From the oven you are going to supply the heat to the boiler. Then in the boiler that water is converted into the steam. Then that steam is used to run the steam turbine or any other purpose, or the any other application purpose. Okay, so like that, this is one example for the external combustion engine. External combustion engine means what? The fuel so that will going to burn outside the engine cylinder. Okay, so that is the external combustion engine. And now you come particularly IC engine. The name again itself is indicating that IC engine means internal combustion engines. Okay, that internal combustion engine, this is also heat engine, which converts the heat energy released by the combustion of fuel takes place inside the engine cylinder into a mechanical work. Okay, so in both the basically this heat engine is divided into two groups, that is external combustion engine and the internal combustion engine. In the external combustion engine, that fuel you going to burn outside the engine cylinder, again that heat energy what you going to generate it due to combustion of that fuel, that you can use it for again convert into a mechanical work only. Okay, so I give one example is a boiler. Okay, so similarly IC engine, in the IC engine means what, the burning of that fuels inside the engine cylinder. So engine, in the engine cylinder itself that heat energy will get generated, so that heat energy is converted into a mechanical work by the piston cylinder arrangement like that. Okay, so it is as for IC engine is the best example for petrol and diesel engines. Okay, these are the internal combustion engines. Okay, though I think you people can clear about this basic terminologies of these engines, that is a heat engine, what is a heat engine, and how you going to classify the heat engines. Basically there are two types, that is the external combustion engines and the internal combustion engines. In simple words you can remember that is external combustion engine means the fuel you going to burn outside the engine cylinder, so that is the external combustion engine. In internal combustion engine means what, the fuel you going to burn inside the engine cylinder. Okay, so at the end you going to convert that heat energy into mechanical energy. Okay, so this is about the basics about the basic terminology or definition of the IC engine. So now you can move to the classification of IC engine. So you will know the what is a heat engine, what is the external combustion engine, and what is the IC engine. Okay, so now in detail you go with the IC engines. So for syllabus you people can only study about the IC engines, not you people are not going to concentrate or you are not going to study about the external combustion engines. Clear? So now if you come to the classification of IC engine, it is very important. In exam they may ask some 6 to 8 marks, so give the brief classification of the IC engines. Okay, so we people are going to classify the IC engine based on the different categories. You will go with the one by one. So first step or the first category is that according to the type of fuel used in the engine. Okay, so what type of fuel you are using in the engine, so based on the type of fuel you are classifying the IC engine into 4 types. That first one is a petrol engine, diesel engine, gas engine and biofuel engines. Okay, so because in the petrol engine you are using the fuel as a petrol. Okay, you cannot use the diesel here, only pure petrol you can make use in this engine. And diesel engine, already diesel is also fuel, so only particular diesel you can use in this engine, so that is the diesel engines. And the gas engines, gas engine means what, you can use any air or any burning gases in the engines to run the engine or to convert that energy into the mechanical energy, heat energy into the mechanical energy, that is a gas engine. And biofuel engines, because nowadays so you are concentrating on the biodiesel as the alternate fuels. Okay, so in engine if you are going to use the biofuel engines, then that kind of those type of engines are called as biofuel engines. Clear? So based on the type of fuel used in the engines, you are categorized into 4 types of engines: petrol engine, diesel engine, gas engine, biofuel engines. Okay, so this is the first category. So next move to the second type, that is according to the number of strokes per cycle. So that is basically, I think you are know about this, that is a 4-stroke engine and 2-stroke engine. Okay, so number of cycles that will going to happen during the working of that engines, that is a 4-stroke engine and 2-stroke engines. And third category is according to the method of ignition, how that ignition or the burning of fuel will takes place. So based on that, so you are classifying the IC engine into 2 types, that is a spark ignition, that is SI engine, and the compression ignition, that is the CI engine. Okay, so spark ignition means what, so in order to initiate the burning or the combustion of fuel by producing a small electric spark in the engine cylinder, then the engine will, that is fuel will going to start burning and heat energy, huge quantity of heat energy will get generated. Okay, that is a SI engine. Compression ignition means what? That is that fuel or the air or the that will going to compress in the engine cylinder, and at the end of the compression, so you going to ignite, some ignition will going to initiate, and then automatically that burning of the fuel will starts. So that is what the SI and CI engine. So next, according to the cycle of combustion, that is Otto cycle engine, diesel cycle engine and dual combustion engine. So next, fifth one is according to the number of cylinder used, that is single cylinder, multi-cylinder engines. The sixth category is according to the arrangement of cylinder. That is very important, because we have the so many types of vehicles or the engines in the market, because how you going to arrange the cylinders in the engine, that is important. Based on the vertical type, if you place the cylinder in vertical, so then you can call it as a vertical engine, horizontal engine, inline engine, radial engine, V engine, opposed type engines. Okay, so that is based on the arrangement of cylinder. So next, seventh one is according to method of cooling. So how you going to, because engine means what? The huge, you are dealing with the heat, so automatically the heat will get generated in the engine cylinder. You can going to cool the engine also. How you going to cool that engine? So that is based on that also you are going to classify the engines, air cooled engines and the water cooled engines, and oil cooled engines also are there. Okay, so these are based on the cooling system. Then according to their use, stationary engine, automobile engine, marine engines, aircraft engines. Okay, so this is about the brief classification of the IC engines. This is very important, and they may ask in the exam, give the classification of the IC engine. So you are classifying the IC engines on different categories, about 8 categories. Okay, so you go through that list, and after this, once you classify the IC engine, if you take any internal combustion engine, so you have internal combustion engine means what? There is a cylinder and there is a piston and there is a inlet and outlet port. It is a piston cylinder arrangement. Okay, so you people can know some terminologies about the IC engine, because I am going to representing here one simple sketch about that engine piston cylinder arrangement. So here this is the inlet port. Okay, through this inlet port, that fresh air and fuel air mixture will get entered into the engine cylinder. This is the engine cylinder, and this one more exhaust, it is the outlet port or the exhaust, and there is a volumes. I think this is a cylinder height. Okay, the cylinder is having some limit, that is the bottom dead center and the top dead center. So within that two centers, the piston will going to move inside the engine cylinder to convert that heat energy into the mechanical energy. So here I am mentioning here top dead center means extreme part or the position. So that is the bottom dead center, and this is a cylinder, and this is a piston with a connecting rod, and this is a bore. Diameter of the cylinder, you can call it as a bore. And the movement, the length, that what length that piston is going to move inside the engine cylinder, that you can call it as a stroke length. That is a stroke. And there is one more, there different volumes are there in the engine cylinder, that is the clearance volume, shaft volume and the total volume. The clearance volume means what? So when the piston is at the top dead center, so whatever the volume it is there in the top of the piston, always that volume is remains same in the engine cylinder, that is the clearance volume, and that is the stroke volume. Okay, so that is there are two very important volumes in the engine cylinder, that is clearance volume and the stroke volumes. So this is about the some terminologies. So I am given in sentence also, what is the bore? Bore is a inside diameter of the engine cylinder. Okay, and what is the top dead center? The extreme position of the piston near to the cylinder head is called a top dead center. What is the bottom dead center? That is a BDC. The extreme position of the piston near to the crankshaft is called a bottom dead center. What is the stroke? It is very important. What is the stroke? It is a linear distance covered by the piston from TDC to BDC or BDC to TDC. Once that piston will move from top dead center to the bottom dead center, or the bottom dead center to the top dead center, that you can call it in one stroke. So then what about the clearance volume? It is a volume of the cylinder above the top of the piston when the piston is at the TDC, means at the top dead center. What is the shaft volume or the stroke volume? It is a volume displaced by the piston as it moves from BDC to TDC or TDC to BDC. So that is the shaft volume or the clearance that is stroke volume. So next is very important term is the compression ratio. Okay, the ratio of the total cylinder volume to the clearance volume is called a compression ratio. Okay, mathematical equation is here, that is R is equal to, basically the compression ratio you are going to represent it by the letter small case, that is R. Okay, that is basically we know that what is the compression ratio. It is the ratio of total cylinder volume to the clearance volume. Total cylinder volume means what? That is clearance volume plus stroke volume. Together you can call it the total volume and divided by clearance volume. Okay, Vt by Vc. That simple mathematical equation as I mentioned here. You just see this. Vs is the stroke volume plus clearance volume. This become total volume and divided by that is the clearance volume. Okay, so this is about the compression ratio. Okay, so next you can start with the performance of the IC engines. These things will do at the end, because after if you some more theory content is there in this, you people can go into studied about the combustion in SI and CI engines. After that you can going to cover about this performance equations. Okay, so now I am going to stop it here only. So in this video lecture you are covered about the basics of the IC engine. So what is the heat engine, so how you going to classify that heat engines, and the classification of IC engines, and some very important terminologies which are used in the IC engine that you are seeing here. So you can go through this. So remaining things you are going to do it in the next video lecture. So thank you.